What is up, everybody? Welcome back to another video. Today we're going to be doing 2019 exam 3, the last and final exam before the actual final. So for this one, number 1 is going to be the same on all tests. So this number 1 is probably going to be repeated for if I do future years. It's just going to be the same video for number 1. And number 1 goes off with derive the expressions for IR and I theta components of the velocity and acceleration. I'm going to be working it out how my teacher taught me and how I did on the test and got full points for that question. So let's go ahead and get started. So the first thing you write is the R vector is equal to IR. Okay, R is equal to IR times R. That's what the R vector is equal to. And then after that, you're supposed to memorize IR is equal to cosine theta I hat plus sine theta j hat. So those are the two main things you're going to need. Then after that, you're going to have to take the derivative of both of them, dir d theta, and then the derivative of that is going to be di theta. So dir over d theta. So I heard this one is called chain rule, or yeah, it's called chain rule. So you just take the derivative of that. It's going to be negative sine theta I plus cosine theta j hat, and then take d theta, which is equal to, and this is equal to I theta. This is equal to I theta. So now you take the derivative of that, and that's going to be negative cosine theta I hat minus sine theta j hat, and that is equal to negative IR. As you can tell, this is just a negative version of that. So those are the main things you're going to need. Then on the side, you can write the general equations. D omega over dt is equal to alpha, and d theta over dt is equal to omega. Okay. So now we're going to take both of these with respect to time. So let's do di theta over dt. So this is going to be chain rule. So this is equal to di theta over d theta times d theta over dt, because it's just the same thing. If you cross these out, it's going to be di theta over dt. So now just substitute it. You know d theta dt is going to be omega, and you know di theta over d theta is negative IR. So it's going to be negative omega IR. And that's the first part. Now we're going to do the same thing for dir. dir dt is equal to dir d theta over dt. dir d theta is just I theta, so this is going to be omega I theta. So that's the second part you're going to need. So now to find the velocity, we know the formula for velocity is dr over dt. So now we're going to take the product rule, which is equal to dr over dt IR plus R times dir over dt. So that is the product rule. You take the derivative of the first term, multiply by the second, take the derivative of the second term, multiply by the first. So yeah, okay, so now since we have that, all you gotta do is substitute dir dt. You know that's gonna be omega I theta, and that's all, and that's going to be the formula. So now we know V is equal to dr over dt IR plus R omega I theta, and that is the formula for the V. And yeah, that's the right formula for the V, and that's the first part. Now you're going to do the acceleration, which is right here. Acceleration is the derivative dv dt. That's the formula. So all you're gonna have to do is do the same product rule, but now you're gonna have to do it for each term in this equation. So let's go ahead and get started. It's gonna be equal to d squared r over dt squared times ir plus dr dt plus dr dt dir dt. Okay? Next, you're going to add those plus dr dt omega I theta plus d omega over dt ri omega plus d I theta over dt r omega. Okay, so that is the whole formula for acceleration. Next, we're going to substitute the terms in. So for dir dt, where you know what it equals, it's right here. This is equal to theta I theta. And we know what d omega dt is. This is equal to alpha, as you see up there. And you know what di theta over dt is. That is equal to negative omega ir. And those are the three things you can substitute in. And after you do that and substitute like terms, the final answer is going to be A is equal to d squared r over dt squared, and then minus r omega squared. We're going to put the IRs together. This is negative omega r omega squared. So we're going to put the IRs together, and that's IR. Then parentheses, and that is all the IR. Next, we're going to do 2 dr dt, because that's dr dt omega. So there's two of them, 2 dr dt omega, and then you have r alpha, because you substituted that in, and you parentheses that and put I theta, and that should be the final answer for acceleration for number 1. Yeah, that is the final answer right there. And if you write all this down on your test, you should get all 25 points for that question. Okay, now moving on to number 2. In another galaxy far, far away, a small moon mass m travels in a circle of radius r about the fixed sun. The force exerted by the sun on the moon is not the usual force of gravity. It's attractive and has magnitude F equals cm over r4, where c is a constant and r is the distance. Find the total energy, kinetic, and potential for the moon as a function of r. So let's write down what they gave us. They gave us this formula right here. So they gave us this F is equal to cm over r4. Okay, they gave us that. And so they want us to find the total energy, kinetic plus potential. So for this one, let's just start off by writing the force formula. So force is equal to mass times acceleration. And by now you should know what acceleration is equal. We just worked it out in the last question. D squared r over dt squared minus r omega squared IR plus m. Yeah, this will be an m because it's mass times acceleration. M2 dr dt omega plus r alpha I theta. Okay, so that is the formula for force. So they told us the r is fixed, which means it does not change. So that's going to be equal to 0. That's going to be equal to 0 because r does not change. And now let's write what we have. Oh, no, this whole side is going to be equal to 0. Yeah, this whole side is going to be equal to 0 because there's no tangential acceleration. It's just moving in a fixed r. There's no tangential acceleration at all. So the whole thing is going to be 0. So the only thing we're left with is negative mr omega squared. And that is the force. So we're given the force, so we can automatically just solve for it. So we can set, this is going to be negative because it says it's attractive. So we can set negative Cm over R4 is equal to negative Mr omega squared. And we can just solve for omega squared because we're going to need it for kinetic energy. So let's just proceed. We can get rid of the negatives and divide by M and multiply by R. And that's going to equal C over R5. Okay. Omega squared is equal to C over R5. And that is, and that is the, okay, now we know what omega squared is. So now we can solve for the, let's do potential energy first. Potential energy. So U of x is equal to negative integral f of x dx. So now take the negative integral of negative C m over R4 and dr. So yeah, take it with respect to R, and then that's going to equal to negative C over 3, negative C over 3 m over R cubed plus C. That's if you take derivative. If you take derivative, you're going to add 1 and subtract and divide by 3. So it's going to be negative CMR negative 4. You add 1, it's going to be negative 3. Then you divide by negative 3, and that is what it equals to. So that is the potential energy right here. We got the potential energy. Now we just got to solve for the kinetic energy. So the kinetic energy, this is the potential kinetic energy. Let's do it right here. Is equal to half I omega squared. Because this is going to be, because this is circular motion, it's not mv squared no more. It's going to be half I omega squared. And we can just substitute stuff in. Half, we know I is equal to mr squared, and we know omega squared is equal to C over R5. And now to simplify, that's R squared, R5. We can just make it, what can we equal to? You can do half MC over R cubed. And that is, C over R cubed. And that's going to be, that's going to be the, okay. Yeah, so C over R cubed, okay? So now, to find the total energy is equal to kinetic plus potential. So now, let's set them equal, let's add them together. Half MC over R cubed minus 1 over 3 C m over R cubed, and you don't have to include the constant because the constant is 0. So now, just taking this, put this as 3 over 6 minus 2 over 6 is going to be equal to 1 over 6 CMMC is the same thing, CM over R cubed, CM over R cubed, and that should be the total energy. That should be the total energy, 1 over 6 CM over R cubed. Okay, moving on to number 3. You guys can see the question right here. You guys can see the question right here on the screen. So pause, take a picture of it if you need to, and I'm just going to go straight into working the question. So for this question, they want us to, there's 3 parts. So part A, what is the angular velocity of the rod as a function of time? So let's start off with this is going to be an angular momentum question. Let's just start off with writing the formulas we're going to be using. L is equal to R cross P, which is equal to I omega, which is equal to mr squared omega, mr, let me just erase that, mr squared omega, okay, which is equal to mr squared omega, which is equal to mr v theta, okay? And we know this is going to be Li is equal to Lf because momentum is conserved. Torque is 0. So let's start off with writing the initial momentum of the rod. So initially, we have m1 s squared omega naught. We're told m1 is going to be m1 s squared omega naught. And we use this formula right here. The radius is s. Omega naught is the initial omega. And then what do we have? Plus M2. We have a mass M2, but in the beginning there is 0 is in the radius, so there's 0 is 0. This is 0 radius because it's right in the middle. There's no radius distance, so 0. So that one is just going to be equal to M1 S squared omega naught. Now let's go on to the final momentum. So in the final, we're going to have M1 S squared, but this time it's going to be called omega. And then we're going to have M2, but this time the radius is going to be CT. Because in the question it tells us that it's given by CT, the distance, and we have omega this time. We have omega, because that is going to be, yeah, we have omega this time. Oh yeah, this one is going to be CT squared. Yeah, we're using this formula, CT squared omega, because there's no velocity they gave us. They gave us omega with it. So, okay, now since we have that, let's just go ahead, set them equal to each other. M1 S squared omega naught is equal to, let me see if I can simplify, is equal to omega M1 S squared plus M2 CT squared. Okay? Now to find omega, which is what we're trying to find, just divide both sides by whatever that value is. M1 S squared omega naught over M1 S squared plus M2 CT squared. And that should be the final answer. And I think, yep, that's the final answer. So that is omega right there. That's part A. That's part A. Okay? So part A is done. Now part B, it says, what is the angular velocity of the rod when object 2 reaches the end of the rod? When object 2 reaches the end, we're just going to be doing the same thing. Li equals Lf. So this one is going to be Li equals Lf. And initially, it's still going to be the same initial. So it's going to be M1 S squared omega naught. But this time, the final is going to change. So it's going to be M1 S squared omega. It's going to be M1 S squared omega. Just like that right there. But this time is going to be different. This one is also going to have a distance S squared omega because it goes all the way. Because it goes all the way, so they're both going to have a distance S because it reaches the end of the rod. So now we're just going to solve for, you're just going to solve for omega, which is the same exact thing that you did before. So this is equal to omega M1 S squared plus M2 S squared, and that's equal to M1 S squared omega naught. So divide both sides. Omega is going to be equal to M1 S squared omega naught over M1 S squared plus M2 S squared. And that should be the answer. Yeah, it's the same answer that they got. Yeah, it's the same answer they got. And that is the answer for part B. And now for part C. For part C, they ask us, if the object 2 leaves the rod when it reaches the end with a velocity of magnitude Vf parallel to the rod, what will be the angular velocity of the rod after that object leaves? So this one is the same, Li equals Lf. We're going to have the same initial velocity, S squared omega naught, and this is going to be equal to, the final is going to be equal to M1 S squared omega only. It's only going to be equal to M1 S squared omega, just because the thing leaves the rod. What leaves the rod? Yeah, just because object 2 leaves the rod, so it's not part of the momentum thing anymore. Once it leaves the rod, it's not part of it, so it's not going to be in here. We're not going to have no M2, and the final answer is just going to be omega is equal to M1 S squared omega naught over M1 S squared. And that is the final answer for part C. and yeah, they didn't write that there, but I think it's the same thing because they just cancel out, those cancel out, and that is equal to omega naught. So that's the answer they got in the answer key, and that's the final answer. And that's it for problem 3. Okay, last and final question is going to be on the board. It's going to be on the screen right now. As you guys can see the question up there. Pause it, take a screenshot, whatever. And I'm going to get straight into working the question right now. Okay, so for this question, first off, you're going to need to draw like a little free body. You're going to have to draw a free body diagram just to get a gauge. So let's draw the free body diagram of the block. So this one's easy. It's just going to be mg, and that's going to be the tension force for the block. Next, draw the free body diagram for the pulley. So we have a string that's this way, and we have a string that's that way, and this is going to be, this is right here is going to be the tension force, and we're going to make our direction this way. It's good to always make your direction counterclockwise. And then we have the force P. So let's just draw that right there. That's force P, and we have that at an angle. We have that at an angle. Okay, we have that at an angle phi. Hang that at an angle phi. Okay, so that's how you start off the question. Next, just start off with the basic torque formulas. We know the change in torque, you're probably given this on your formula sheet, is equal to I alpha. It's equal to I alpha. Okay, I don't think this marker shows. So, okay, torque is equal to I alpha. So now you just start by doing the torques on every single force. And torque is equal to R cross F. So you're just going to take the radius, which is R. The radius of this is R. So everything is going to have R in it. And F is just the force. So the first one we're going to have is RT. RT is positive because it's moving that way, and we set our direction to be that way. And we're going to set this to be positive, Y, downwards. Okay? Next, we're going to need P cosine theta, that's the force, times R. P cosine theta times R. Cosine is going to be the straight. We're going to need the straight. Force of it, the force that's moving it towards the thing. So we're going to be using P cosine phi, and times R. And those are all the torques that are happening with the pulley. Those are the only torques happening. We only have the P force and the T force, and then you set that equal to I alpha. Okay. After that, also another formula you need to write. It's kind of given, it's kind of something you have to remember. A over R. If you know A is equal to R alpha, alpha is just A over R. So it's kind of like manipulation with the formula. So next, we're going to have to use this one right here. We're going to have to find the force in the Y, which is equal to mg minus T, because we set it down positive, so it's going to be positive, that's going to be negative, is equal to ma. Okay, and we know T minus P cosine theta is equal to A times, this is what we're going to do. Okay, we're going to substitute this into this right now. So this is going to be RT minus P cosine theta times R is equal to IA over R. So we're going to divide both sides by R. So this is going to get rid of that R. That R is going to go away, and this is going to be R squared because we're dividing both sides by R. And then after that, we still have mg minus T is equal to ma. Mg minus T is equal to ma. Okay. So let's solve for T. So T is going to be equal to, based on this formula, T is equal to P cosine theta plus I A over R squared. Okay, now put that over here. Mg minus P cosine theta. Let's just rearrange that one. Minus AI over R squared. We just rearranged this the same exact way to write it. And that is equal to MA. Okay, so next we're going to group the like terms. So we're going to move this to the right side, and this is going to be Mg minus P cosine theta is equal to A, okay? And then we have M plus I over R squared. Let me see, M plus I over R squared, okay? And that's the right formula. And now we can know what A is, just divide both sides. Mg minus P cosine theta over M plus I over R squared. And that is the A. Okay, so now we know the acceleration. Okay, so now we know the acceleration. Yeah, we know the acceleration now. Now it's going to be easier to find the omega, which is what we're looking for. Yeah, to find the angular velocity. We know the formula for angular velocity is equal to the integral of alpha dt, which is equal to ay over r, because alpha right here, we know it's a over r, so it's the same ay over r and dt. So all you gotta do is divide this by r and take the integral with respect to t, and the answer is gonna be, okay, so the r for this is gonna be capital R. So we're gonna divide it by capital R, and we're gonna take the integral. So the final answer is going to be mg minus p cosine theta over r, because you're dividing by r, then put everything inside, m plus I over r squared, and then put a t, because you're taking the integral, and that should be the final answer. And excuse my theta. Theta is phi. Anytime you see theta, it's just phi. I just always write theta. So that should be the final answer. And yep, it's the final answer that they got in the answer key. And yeah, that should be the final answer. This is omega. And it went from here to there. And that is it for 2019 exam 3. Thank you guys for watching the video. Subscribe if you're new, like the video, and good luck on your final. I'm not going to be doing final videos because on the final exams, they already worked it out, so you can already watch it on there. I'm going to do 2018, and I'll see y'all if y'all decide to watch the 2018 version.